NASA is working on a multitude of projects aimed at making space travel possible for humans, and the know-how for most of these projects comes from tests performed on the I.S.S., the International Space Station. In space manufacturing is one of the main goals, and an overview of the current projects in this domain was presented at the recent I.S.S. R&D conference, the most important event about the activities on the I.S.S.
Here are some highlights from the event, with comments from Raymond Clinton, Director of Science and Technology Office at NASA.
In-space manufacturing is a critical technology for logistics reduction, and that's the story right there. The space station logistics model is just not going to work for deep space exploration. You don't have a quick abort capability, you don't have fix and fly capability, and you don't have a resupply capability. So to address some of these challenges, we're developing in-space manufacturing technologies.
The development of in-space manufacturing capabilities is concentrated in three main areas: manufacturing within pressurized volume, manufacturing for the free space, and manufacturing for new space habitats. In this video, we focus on manufacturing within a pressurized volume, which basically means manufacturing inside an environment like the International Space Station.
The challenge of manufacturing within a pressurized volume is to reduce logistics and keep astronauts safe and healthy while they are in transit and on extraterrestrial surfaces. To overcome these challenges, NASA is working on ways to create tools, spares, safe food and medical solutions in orbit. Manufacturing space started in 2014, when Barry Butch Wilmore created a ratchet with a 3D printer developed by Made in Space. Building on the lesson learned, the second step was to develop an additive manufacturing facility, or AMF. A key factor in reducing logistics on the ISS is recycling, and NASA is working on solutions that can recycle material over and over. Here are the details.
Recycling is also a very key technology in being able to recognize logistics reduction. So Tethers Unlimited has flown now the refabricator, its own space station. Its purpose is to recycle Ultim 9085 and do that continuously. Then Tethers recognized that, hey, if we add a sterilizer to the refabricator technology, we could actually have a food and medical grade sterilizer. Now that's also important because a significant fraction of the waste stream on space station comes from food and medical waste. Then common use materials. We challenged industry to take a look at the packaging materials on space station because the packaging materials are also another source of waste and trash on space station. Please see if you can find ways to turn these packaging materials into feedstock so that we can print parts and components and so forth. Tethers was one of those, and they took a novel approach. They said, okay, why don't we start with feedstock and create a packaging material, and then we can convert that back into feedstock. And the material they created is actually quite novel, and you can tailor the strength and stiffness for your particular launch load needs. Cornerstone took another approach. You can see the pink anastatic film. They worked that with a reversible thermopolymer, and they can then modify the viscosity so that we can print with it using an FDM printer. Work that we're doing to be able to print metals in space. There's 4 technologies that we're funding: wire arc through Made in Space, ultrasonic technology through Ultratech. Tethers is leveraging their refabricator experience using CMC to machine the billet using an ingot approach. And then finally we've got TechShot with their simple technology, which is using inductive heating to heat the thin wire and then laser to do the centering of the softened wire. Another bit of experience that we've learned from space station and looking at the problem reports is that a number of the failures that take place are with electronic components. So wouldn't it be great if you're on your deep space mission to have the capability to print whatever you need in the electronics world to replace what's failed? We're working some of that in-house at Marshall. We're partnering with other centers and industry. We're looking at flexible electric circuits, wearable sensors, gas sensors, pressure, temperature, humidity sensors, all kinds of conductive inks, Inconel 718, silver, aluminum tin, and so forth. And then finally really is the crown jewel that Chris Moore talked about a little bit yesterday. That's the multi-material fab lab. We're in the first phase of a three-phase process to be able to print not only with the same machine plastics and metals, and we gave industry a choice of titanium 6.4 or aluminum 7075. Larger build volume, a lot of autonomy, inline quality control and inspection. So we're asking a lot out of industry. The next phase should begin competition no earlier than very late this year or early next year.
There are many other solutions being tested on the I.S.S. and not all of them were presented in detail at this trade show. To find out more about the research conducted on the I.S.S., just click on the link provided.